Okay, now we're going to do the stars. You should have your study guide. Not a good idea. So, a few reminders about the stars while you're getting your papers together. First reminder, stars tell you that you need to pay extra attention to your notes. But it doesn't mean that they're on the test. Sometimes it just means heads up, it could be on the AP test. Sometimes it means heads up, I've seen students make a lot of mistakes. Sometimes it means heads up, we're going to get to this again in a later unit. But there's some stuff where I think you can kind of BS your notes, you can get it out of the book, you can ask somebody and it's fine. The stars mean you need exceptionally good notes. 3 stars means holy crap, you better ask every smart kid and check all the notes and watch the video and make sure you nail it. Because for a number of reasons, those notes might be extra important. Evan, I'm going to throw my key. In the order that they appear on the study guide, starting with the vocab. First and second laws of thermodynamics, 1 star, it will be on the AP test guaranteed. The first and second laws of thermodynamics.
First.
There's either made a law to change its form, but it changes form and follows these laws. First and second laws. Electrical resistivity gets a star. Just a key concept. Energy efficiency gets 1 star. Students, what's a way of measuring energy efficiency? Yes?
Input to output.
Ratio of input to output. That's right. Cogeneration gets a star. Acid mine drainage gets a star.
What was the one before acid mine?
Peat gets a star, and so does depositional basin. Were those added to the vocab, or did we just throw them into the whole unit?
I don't know what those.
Okay, so you can write them on the side somewhere. Peat, like that partially decomposed plant fiber, PEAT.
Oh, I spelled it P-E-T.
Oh, no, not like Peter.
Same it.
Well, Pete.
Get it? And depositional basin gets one. Places where organic material settles, a basin of deposition, depositional basin. Digestion gets 1 star. And what are the 2 possible types of digestion?
I don't know what you're talking about.
What happens in your gut? What happens in your intestine? What happens in your stomach? What happens in your intestine? That's right. Aerobic and anaerobic. The 2 types of digestion, vocab you have to know. Aerobic and anaerobic. Which one of those makes methane? Anaerobic, so good. Fission gets 1 star. Enrichment and moderation each get 1 star. Study goal number 1 gets a star. Was anybody else impressed in that movie about that Volvo car, the LCP 2000? That has like a 3-cylinder engine and gets it like over 100 miles to the gallon back in the 1970s.
Yeah, what is it kind of surprised?
I gotta take a little side trip to talk about it because we should check some of these study goals about the movie now just in case we're all on the same page. Why doesn't everyone drive them? How many?
1,000.
No, 3.
Okay.
Yeah, 3. Because right when they came out with this super efficient car, gasoline prices came back down. We've always had the efficiency technology. We don't always have the demand. The proof is in the pudding. No, they don't. Right now, the best-selling cars in America have very low fuel economy because people aren't motivated to save money on gas. It's like, right now I get to go fishing, no big deal, up the range for $58. Because my boat's pretty efficient, $58 for a day of fishing, that's not that bad. If that cost me $200 to get up there and back, I'm not sure I could go. Same is true for like road tripping and stuff. Right now, I can go all the way to Florida on a couple $100 in my truck. But if the price of gasoline goes up, I'm not going to go to Florida. The thing I find interesting about the LCP 2000 is the technology has always been here. As a matter of fact, 40-year-old technology made like a giant comeback 5 years ago. And everybody was like, oh my God, maybe we could do this. I wonder what mix of federal incentives and legislation would be required to make efficient cars. That is just totally horse crap. Efficient cars are old school. We can make efficient cars all we want. A Honda Civic from the 1980s is more efficient than any car, than the average car made in the year 2015. Oh! Here comes the most amazing fact of the day. Here we go. I've got the way to explain this. Anybody know the first mass-produced car by Ford Motor Company, the Model T? How many of you have heard that? The first mass-produced car, Model T? The first mass-produced vehicle ever made, the Ford Model T, had better fuel economy than the average Ford Motor Company car made in the year 2015. Yeah, I mean, hold on. That's exactly my argument. The efficiency is not the question. We've just chosen other priorities. I want air conditioning. I want to go faster. I want a safer car. I want better brakes. I want a roll cage. I want the airbags. I want a DVD player. I want the ability to haul piles of chicks and kegs of beer. Yes.
TVs everywhere.
Yes. I want big old wheels because I have a small penis complex. Look, we've made cars safer and nobody complains. We've made cars faster and we all seem to like that, I think. And basically, consumers have prioritized other things instead of the efficiency. I think that's a really big deal. I think it's really important to remember that efficiency is there if the demand is there. Volvo made this car and they killed it because nobody wanted to buy it.
Why would they kill it? Why would they take them back? Why wouldn't they just leave them out there?
Well, economies of scale, devoting a few factories and all that workforce without the output, investment. I don't know, bro. That's the economics of this.
No, like they took them back. They could have just.
No, that's a different car. That was like the other
We're
movie.
talking about. All right. Number 2 gets a star.
Come on, Andrew.
Avery Lovin's Secret Megawatt Technologies. Don't remember that guy that looked like Inspector Gadget with like a trench coat
Oh yeah.
and a briefcase? And he opens it up and he's like, woo-hoo-hoo, compact fluorescent. And everybody's like, yeah, bro, we have those all over my house. That's a big deal. The reason I give it a star is not because that technology is cutting edge in 2016. It was actually pretty cutting edge 35 years ago when they made the movie. It's not that impressive now. But again, that term, megawatt, energy efficiency, unused energy, megawatt. Number 4, plant fuel energy is renewable solar energy because it makes the CO2 more useful. Evan, I got you on the phone essay. This time, bro, it's personal. Credit card?
Put it in the butt.
Credit card scanner. Oh, yeah, that's very good. Oh, yeah. Number 6 gets 1 star. 4 got 1, 6 gets 1. The costs and benefits of nuclear, yesterday's warm-up, please don't make me repeat it again. Clean, lots of supply, cheap electricity, highly concentrated, but chance of a meltdown is really sketchy, and then the long-term consequences of the waste is really great. Number 9 gets 3 stars, 11 gets 3 stars. 13 gets a couple stars. 2. 19 gets 3 stars. All the stuff about petroleum and like primary extraction, secondary extraction, tertiary extraction. It's been a long time since we did these assignments. I hope that you have a good memory. Or that you took good notes. That's a good notes. 20 gets a couple of stars. That's where we talked about the impacts of fracking, the pro and con of fracking. 23 gets 2 stars. All the different problems with the petroleum economy. Yeah, that was a long time ago, right?
I wasn't here to see.
Yeah.
Mexico trip.
25 gets 1 star. 26 gets 2.
We talked about how many.
And remember that in 26, where it asks about how to make coal cleaner, there's also that article in the Reader about clean coal, number 40, huh?
Yeah, number 40.
Yeah, that one. Clean coal was number 47. So 26 goes to 47. 27 gets 1 star. Then we get into the stuff you missed because you were in Mexico. 29 gets 2 stars. This stuff. $32 gets 1 star. This stuff. 34 gets 1 star. Never talked about it in class at all. We can do it really quick. Get ready. 34. Biomass is anything that used to be alive, like wood or wood pellets or ethanol, whatever. You can make it into energy a number of ways. Like fermenting into alcohol for cars, or digesting into methane. For natural gas, I know or you can burn it directly just to make a heat source that you can use either for heating your house or to spin a turbine by boiling water. And to answer Cameron's question, we don't consider fossil fuels biomass because they were biomass that's been geologically transformed. So yeah, fossil fuels are made of biomass, but we don't call them biomass anymore because they've been switched around so much already. The chemicals are different because it's heat present.
Wow.
36 gets 3 stars. We spent 2.5 days on it. This stuff, 3 stars.
What do people get wrong about it?
I think people fumble the equation a lot.
Fumble.
Like it really is explicitly 235 plus a neutron makes 236 makes radioactive decay products, and you gotta like word for word that. And I think a lot of kids understand it when they see it, but they can't explain the 3 heat exchange cycles. Like the labeling the parts is just memorization. You memorize it or you don't. Sorry, I don't know. But conceptually, I think the bigger challenge is explaining how heat is transferred. That's why I spent so much time yesterday talking about heat exchange systems. Yeah.
What's like the best way to write How? Like what happens?
Fission, splitting of an atom. The nucleus divides into two. Yeah, that's a fine question. Yeah, I'm sorry to be so colloquial that you're not learning the real thing. Uranium-236 is a large, complicated atom. Because of its inherent instability, it divides into two smaller atoms. Whatever you're going to divide it into, whether it's barium and krypton or tin and molybdenum or any other things that add up to 92 protons, the concept you got to have is that all those elements, protons and neutrons, break and rearrange into smaller atoms. They're going to be extra heavy, they'll continue to decay, they give off radioactivity for a long period of time. Fission. I'm glad we're doing this. We've got a few minutes left. Are there any other questions about 36? Oh, the only other stars that I can give you, one for number 41, the different levels of radioactive waste and then how they're handled differently. And 42, the pro and con of the nuclear power debate. That one gets a star. And again, I want to remind you that the College Board will often ask you pro and con questions. Arguments in favor of and against pesticide, arguments in favor of and against fracking, arguments in favor of and against nuclear energy. I've seen all of those already on the AP test. Well, not the fracking one, but the others. They always have pro-con questions, so it's important to look at both sides of stuff. Make sure you got something to say about them. Are there any questions about the study guide or about Unit 7 or the stuff that I've put stars on? Let them sort of break into the video, please.
Break.